This video is for you, Janet. This is going to be my first video on explaining math, and this is about how to synthesize or interpret an expression like the one you see on the screen here, using the common practice of order of operations, as they say. So let's first talk about what that even means. So if you take like an old solar power calculator and you punch all of these terms in, it will not give you the same answer as a scientific calculator or even Google would these days. And that's because the old calculator just inputs everything from left to right. Doesn't matter how complex the operation is, it just does one after another, and it reads it the way you would read words on a page, from left to right. However, that's very, very limiting, and it turns out there's a lot more that you can do when you have more flexibility for what order to do things in. And there is a default order meant for convenience, which is what people mean by order of operations. But you're also not limited to that order, because you can change the order anytime you like, and I'll get into that in a moment. So let's first of all talk about the order of operations. What is that? Well, it's a hierarchy. The order of operations is based on a hierarchy, and that hierarchy comes from the complexity of the operations. So the bottom of the hierarchy is your most basic symbols, like your most basic operations. The very first operation we learn is addition, and then in line with addition is subtraction, to undo addition. And it turns out that subtraction really is also just addition, but by a different number. For example, if we were going to take 5 minus 3, we could think of that as taking 3 away from 5, or we could also think of starting at 5 and then adding 3, but with the opposite sign, adding a negative 3 to 5. You would get the same thing. So you could think of all of that subtraction just bundled into addition with this, like, switching the sign. And then on the next level, this would actually, let me back up for a second. So this is the simplest. This is the simplest level of complexity. And then we have the middle level of complexity. And so this is an operation of multiplication based on addition. So as an example, if I did 2 times 3, I'm going to use a dot here. I'm not going to use a dot here because a dot's harder to see and interpret. 2 times 3 is 3 2s, 1, 2, 3, all added together. And so you have a more complex operation built on addition, which is multiplication, specifically from repeated addition. And then you have its kind of partner in crime here of division. And very similarly to subtraction before, right here, division can be thought of as multiplication, not by the same number, but if I wanted to, say, divide 10 by 2, I could also think of that as a multiplication, and then I just switch my divisor into a multiplier. Instead of dividing by 2, we multiply by a half. And in general, just like with subtraction, switching to a negative, with multiplication, you're switching it to a reciprocal or a multiplicative opposite number. So there's the middle level. And then finally, the most... That was Abby. The most complex level is exponents. And you might say, like, well, what about undoing exponents? Well, there is something like this with roots that are also exponents, but roots kind of have a syntax built into them, which is nice. Like how far the root stretches over. Does it end here, or does it end here? That really lets you specify what you're taking a square root of. So it has this kind of syntax automatically built in. And so does the other inverse. These are exponents aren't as nice as addition or multiplication. They are more complex, and you lose a lot of the key properties that addition and multiplication have. So we're gonna leave out the opposites, yes, plural opposites of exponents. I'm just going to put a smiley face here because there's nothing here to worry about to pair up with exponents as far as syntax. So that's how the structure goes. And the order that we're going to do this in is, I would say, similar to how you would look at or interpret a program or many other things in life. You start by parsing the most complex things first, and then you go simpler and simpler. So we're going to start at this level. Oh no, there we go. It seems like it's working. No, it's not. Okay, hang on a moment. Hopefully that works now. Yes, it does. Okay, so we'll start here, the most complex, then go to the middle, and then finally the simplest level. We'll go and do those one by one. Now, this sounds very draconian, very fixed in order, and it is. So we need flexibility to be able to change the order. This is the kind of default, or the order you would naturally go in when you see an expression like the one you see in front of you. However, sometimes you might want to do addition before multiplication or addition before exponents. And if you ever want to change up the order, we have parentheses. Maybe I should say can change the order. Parentheses can change the order. So that's why usually if you're told PEMDAS, you have this acronym and they put parentheses first. If parentheses didn't go first, they wouldn't be powerful enough to be able to change the order of complexity that comes as a default. So let me move this a little bit. There we go. Okay, hopefully this is better centered. So let's examine how to approach this problem here with that order in mind. Hi. Go, please.
Okay.
Thank you. Okay, so where was I? With that order in mind, something. Oh yeah, so here is the first expression inside the parentheses. We're going to focus on that first because parentheses says this is an expression. With no interaction with anything outside the parentheses. So let's figure out what this is. And inside the parentheses, we have 2 cubed divided by 4 minus 2 squared. Now let's just start with this and go through this natural order. There are no more parentheses here. So let's go through most complex to simplest and examine, reduce the complexity here. So starting with the most complex, we have exponents. In this case, 2 is being cubed and there's another 2 being squared. What is 2 cubed? 2 times 2 times 2 is 8. Now we're dividing by 4, then we're subtracting, and then 2 squared is 4. So this is 8 divided by 4, and then also minus 4. All right, so that's all set. Now let's go to the middle term. You know what? Use red. Purple. I'm going to use purple for this. So for the middle level, this is multiplication / division. That's both of these. If I look here, I see division, just one division. So now I'm going to interpret this division. 8 divided by 4 is 2. So I have this original expression is equal to that, and finally we get -2. And that's what's inside the parentheses. So I can take all of this here, if I get that, well, it's probably close enough. All right, and copy it. Hopefully I copied everything. All right, I hope this doesn't get too messy. All right, so this guy is over here, and I'll kind of try to separate all these out here. So hopefully this is still a good presentation here. So this part right here, that was, actually I'll just replace it. Why not? I know what it is. It is -2. Okay, now that we know this is -2, we can go down the hierarchy again. So what are the most complex operations happening here? Well, that's exponents. And I see a squared here, and a cubed here, and a squared here. So I'm squaring 3, cubing -2, and squaring 5. So 3 squared is 9. -2 squared is -2 times -2, which is 4, +4, and then we switch signs again to -8. So 9 plus -8, and then over here this is 5 squared, which is 25, 5 times 5, and multiplying that by 3, I've got this 2 here that I'm subtracting, and I don't want to forget that 2 in the front either. Move that over a little bit and put an equal sign there. Okay, great. So that original expression is equal to this. I just put in a -2, simplified some terms by starting at the most complex level, and now we're going to do the middle level. The middle level is, actually I'm going to do purple again so I can contrast the colors a little bit. So the middle level was multiplication and division. So I see a multiplication here and a multiplication here, no division, so I think we're set. So in purple I have 2 times 9, which is 18, and over here I have 25 times 3, which is 75, and everything else is staying the same. So 18 plus -8 minus 2, and then finally plus 75. And now everything is reduced to the bottom level. Boom. So we just have addition and subtraction left. So I've got 18 minus 8, that's 10, or plus -8, same thing. So we're at 10 so far. Now I subtract 2, we're down to 8. Now we're going to add 75. If I add 75 to 8, I get 83. And that's it. That's this whole thing simplified to one number, which is 83. There you go. Hope that's helpful. Thanks for watching. And if there's a next one, I'll hopefully see you on the next one.